This video continues the series where I've been walking through a real end-to-end example of specification-driven development using GitHub's Spec-Kit applied to a concrete business problem, building a virtual assistant to help solve the New York Times connection puzzle. As a reminder, the connection puzzle represents a deceptively simple challenge. You're given a grid of 16 words and asked to identify four groups of four words that share a common connection. What makes this difficult is the nuance of natural language. Many words can plausibly fit into multiple groups, and the subtle differences in meaning can easily lead you down the wrong path. That ambiguity makes this an ideal problem for exploring how large language models can assist while still requiring human judgment and oversight. In the earlier videos, I showed how I use GitHub Spec-Kit methodology to incrementally build this web-based assistant, starting with the project structure and UI, then layering an LLM-powered reasoning and multi-provider support. Spec-Kit itself is an open-source framework designed to support specification-driven development, where the emphasis is on clearly defining what you want to build before moving on to how it gets implemented. If you want to go deeper into Spec-Kit, I included links in the description to several walkthrough videos that explain how it works, what's happening under the hood, and why it's such a strong fit for AI assistant agentic development. Now let's quickly recap where this project stood coming into Phase 4. In Phase 1, the focus was on foundations. I established the overall project structure, built the initial web UI, implemented a React front-end using TypeScript, and created a Python backend. At this stage, the backend was mostly stubbed out so the front-end could be tested independently. I also put a testing framework in place early, which becomes important later. In Phase 2, the backend was enhanced to actually use large language models to generate puzzle solutions. The system was designed to support multiple LLM providers, specifically OpenAI and Ollama, and the web UI was updated to let users switch between them. Then in Phase 3, I improved the usability of the application by adding left-hand navigation sidebar, making it easier to expand functionality over time. This brings us to Phase 4, which is the focus of this video. In under 4 hours of work, Phase 4 was able to allow users to initialize a puzzle directly from an image. On the front end, that meant updating the web UI so a user could simply copy and paste an image of the connection puzzle into the app. On the back end, it required building a new service that sends the image to an LLM and extracts the 16 words from the grid. And just as importantly, updated both the front end and back end tests, maintaining at least 80% coverage. Before writing any code, I use Spec-Kit inside VSCode agent mode with GitHub Copilot to drive the entire workflow. This table shows how the work broke down. Drafting the initial specification took about an hour. Reviewing and updating the project constitution took only a few minutes. From there, I moved through the Spec-Kit steps: specify, clarify, plan, primarily using Claude Sonnet 4.5 for its strength in longer form reasoning and planning. What's striking here is that the work took about 167 minutes, or roughly 2¾ hours. The actual implementation, the /implement step, plus a small amount of code fix-up took just under 1 hour. That pattern is worth emphasizing. In agentic workflow, the majority of efforts shift toward thinking, specification, and validation rather than typing code. This slide shows the high-level specification used to drive Spec-Kit. These high-level specs define the UI behavior, the new backend endpoint, request and response schemas, error handling, and even constraints like maximum image size. Spec-Kit used the high-level specifications and refined it through the steps of /specify, /clarify, /plan, /test to remove ambiguity and fill gaps before invoking /implement to generate code. By the time the agent started generating code, the expectations were explicit. What data comes in, what data goes out, what functions need to accomplish, what technology to use, and how errors are handled. This is where spec-driven development really pays off. The agent isn't guessing, it's executing against a clear, detailed set of requirements. To really drive this point home, I compared the Spec-Kit execution to a traditional estimate generated by Claude Sonnet 4.5. Based on the task breakdown alone, the same feature was estimated at multiple days of work by a human developer, even for the MVP. Using specification-driven agent-assisted development, the core implementation and fix-up took 56 minutes. That doesn't mean the agent replaced the developer. Human oversight was still essential, reviewing specs, validating assumptions, catching edge cases. But the role of the developer shifted from manually writing code line by line to directing, verifying, and refining. And that ultimately is the takeaway from this project. Specification-driven development combined with agentic tooling like Spec-Kit and VSCode agent mode doesn't make coding faster, it fundamentally changes where your time goes and how software gets built. And now, for the rest of the video, I'll show you using how I use Spec-Kit to carry out the steps I just described. Alright, now first we start off with drafting the high-level specifications. So in this, I engaged with VSCode in agent mode and using a combination of GPT-4.1 and GPT-5 Mini, engaging in a dialogue with the agent to help create the high-level specifications. These specifications would then be used later on when I'm using Spec-Kit to derive detailed requirements. Once the high-level specifications were in place, I then, as a safety check, so to speak, used it to evaluate the Spec-Kit constitution that's currently in play for the project, just to make sure if there were things missing or I needed to add stuff to the constitution to account for some of these newer level requirements. Alright, I'm now starting to generate the high-level specification. Here I'm asking the agent to help draw an illustration of the web UI. I'm using ASCII diagram to show the web page. Here it's put out the image where I want the puzzle image to be pasted, some drop-down lists, and added a button. So these are giving me the basic structure of the new web UI. I've moved this into a markdown language, which will be a markdown file that'll be used to build out the rest of the high-level specification. So here I'm now describing just a high-level concept of the new web UI, describing the different parts of the web interface. And I'm now providing more details of each of the elements on the web page. Okay, now it looks like that the web UI looks reasonable. Now I'm starting to talk about some of the behavior. So what should happen when the user clicks the button? So for this, I'm actually interrogating the agent. Since I didn't write all the code, I'm asking the agent for some questions about the code, where things are located, so I can look at the source code, so that as I fill in these functional requirements, I'm making use of consistent terminology that's in the code base. So this is where having been able to use the agent to help figure out, answer questions about the code base was useful for me. And this is now, I'm looking at parts of the front-end front-end server. So again, this is basically for me to be able to use consistent terminology as I write out the high-level specification, so that when the Spec-Kit process generates code, it's using same consistent terminology, so there's no confusion or ambiguity about what needs to change. We'll just let this finish up, and I'll come back on in a few seconds to continue the narration. All right, this is now where we actually start making use of Spec-Kit. So for this, starting with the /specify command, from this we'll derive from the high-level specifications, detailed user stories, and functional requirements. And once that's done, use the clarify command to identify any gaps or ambiguities that are in the detailed specifications. We now take the high-level specifications we just defined and provide it to Spec-Kit /specify command, where it will now expand it into detailed specifications. These detailed specifications will include user acceptance criteria, user stories, and functional requirements. I'm now in the middle of the screen. You can see I'm now manually scrolling through the generated detailed specifications. Once I'm done with my manual review, I'll ask the clarify command of Spec-Kit to identify any gaps, and if there are any, I'll address those. Once that's done, then we'll use the /plan to establish the technical implementation plan. So in the prior slides, we were describing what needed to be done. With the /plan, we're now talking about how those things should be done through the technical implementation. Once the technical plan was created, the agent identified that there were some gaps that needed to be addressed. So this led into some manual work for the research phase, and then followed by some additional manual work for design and contracts phase. These basically involved me having to manually type in answers to questions that the agent had raised about the technical plan. Now, with the detailed specifications complete, we'll now use Spec-Kit /plan command to build out the technical implementation plan. Part of this work will include a research phase where I have to answer questions that the agent came up with regarding the use of technology. And another part of this will be some design work where I clarify any ambiguities in some of the design for interface specifications. We'll let this part of the video fast forward, and I'll rejoin you in about a minute to continue the narration. Once the technical plan was finalized, we then used /test to generate a detailed task list. This was then followed by the /analyze to validate that the detailed task list against the functional requirements and technical plan, and to address any gaps that surfaced. Now, taking the finalized technical plan and using /task, we now create a detailed task list for how to implement the changes. Once those task list was created, I then used the /analyze command to identify any gaps or issues in the tasks that were created. The agent did identify a few high priority ones, which I then engaged in a dialogue with the agent to resolve those high critical issues. We'll now let the video continue and fast forward, and I'll join you in about 30 seconds to continue the narration. Once all of that was done, now we do, I guess, the fun part of actually doing the /implement to actually generate the software changes required to satisfy the detailed specifications. This part of the video is about 2 minutes long and represents about 44 minutes of real-time work. I encourage you to watch this segment so you can see how the agent using a test-driven approach defines a task before implementing the code, and then uses the test to confirm that the code it generated is correct. So I'll rejoin you in about a minute and a half to continue the narration. Once the agent finished implementing the software changes, I then ran a test and noticed that there were some minor errors. So from that, I actually engaged with the agent in some structured dialogue to to figure out root cause of the issues, the agent to come up with recommendations to fix it, and then once I approved those recommendations, the agent then fixed those issues. In this section of the video, I'm engaging with the agent to find root cause for the errors that were noted, have the agent make recommendations. I'll review the recommendations, and once I approve the recommendations, the agent will implement the fix. I'll come back on in about 45 seconds to continue the narration. Okay, now we believe all the errors have been fixed. So now let's give this a test. We're going to copy the puzzle image, paste it in our UI, and select the right LLM to interpret the image. And we're able to extract the words. So now let's double check this. Let's compare the words on the left with the words on the right side, and it looks like we're matching all the words that are in the original puzzle image on the left. These were the words that are extracted into the puzzle. All right, with that, we'll now start solving. We'll use OpenAI with ChatGPT 5 Mini, and then we'll ask for our first recommendation. All right, we now have our first recommendation, and we're now going to it's, I guess the first group of 4 are types of pants, so we're going to select those words in the puzzle and click submit. And we are correct. And in fact, the puzzle says these are pant styles, which matched our reasons. So now let's get our next guess. All right, we now have the next guess, and it's saying these 4 are connected because they're Major League Baseball players. So let's give this a try. And it's correct. These apparently are New York Mets legends. So it looks like we got the blue group. So we'll mark that we got that correct. So let's go for our third group of 4 words. All right, looks like we have the next set of 4 words, which says words of French origin. So let's give this a try. Oh, and it's a mistake. It's a one-away error. So let's indicate that to the assistant. And now we have 1 mistake and found 2 correct ones. So let's ask again for the next group of 4 words, which group, and hopefully we won't make the same mistake. Alright, looks like we have the next recommendation. It says personal names or titles. Let's see what this says. Nope. This is completely incorrect, so we'll mark this as incorrect. And then alright, so we've marked it as incorrect. So now let's actually change the LLM from GPT-5 mini to GPT-5 and see what happens. So now we have two correct groups and two errors. We're only allowed two more errors before we fail this puzzle. So let's try a higher level LLM, and hopefully this will get us a correct grouping. And now we have our next recommendation. It says words with a silent T. So let's give this a try. Yep, and that's correct. And it's the green group, and the connection is a silent T. All right, now we're down to just the last four words. So those obviously make the correct group. But now the question is, well, what's the connection between these four groups? All right, and now we have recommendation. And if we add one letter, these will be mystic names. So I guess like her is Hera, Hercule is Hercules, maybe Ares. All right, let's see this. Uh, yeah, and let's go back. And it says, yeah, Greek mythological figures minus a letter. So we got the last purple group, and we've solved the problem, solved the puzzle. That's great. So what's the bottom line? A new UI and backend service were delivered in about 3 3/4 hours. That includes roughly 700 lines of backend code and tests and about 2,300 lines on the front end. Approximately 2 3/4 hours were spent planning the work, and just about 1 hour was spent doing the actual implementation. This is clearly an example of how front-loading clarity dramatically compresses delivery time. The next planned phase of this work is to implement a database to keep track of results and using the virtual assistant to help solve the connection puzzle. As always, if you found this video useful, please like and subscribe to the channel. Thank you for your time, and see you at the next video.